Ever notice that the faster you spin, the heavier your hands start to feel? That is caused by centripetal acceleration. What's really cool about centripetal acceleration is that centripetal force is that it has centripetal acceleration. And the difference between centripetal acceleration and linear acceleration is that centripetal acceleration will not change the speed or the velocity of the object. It will only change the direction. What will actually change the velocity of the object is the radius at which the object is turning.
In fact, the relation between the radius and the velocity of an object, if the centripetal force remains constant, is this square root function here. So we know that the equation for centripetal force is the Fc equals m times the speed squared divided by the radius. So if the centripetal force were to remain constant, if the denominator got bigger, the numerator also has to get bigger. And we know that the mass is constant, and the speed is squared, so the actual value of the speed doesn't have to increase as much as the radius does, which is why we get the square root function.
We actually see this in our experiment when we change the radius from 25 centimeters to 32 centimeters. The average time to complete a cycle is about the same, but with the distance traveled, it makes it the velocity goes from 3.74 to 4.84.
The velocity does not affect Fc by itself. In our experiment, we had a hanging mass attached to our rotating mass with a string. And we know that since the tension in the string is equal everywhere, the hanging mass is the only thing keeping the rotating mass towards the center. So we know that Fg equals Fc. And since we never modified Fg during our experiment, we could determine that the Fc also never changed. So increasing the velocity would only increase the radius, since the Fc always had to remain constant.
Also, the mass inside of the system does not affect Fc. Let's say we're talking about the rotating mass in this case, as long as the radius and the speed remain constant. As Justin just said, Fg is equal to Fc in our experiment, so the only way to actually use a mass to change your Fc would be to change the rotating mass. So you change your Fg, therefore your Fc would be larger or smaller.